Hello class. In this video we're going to talk about factoring using the perfect trinomial square method. The definition for factoring is breaking down or dividing a number into its factors. There's a couple of rules that we need to think about when using perfect trinomial square. Rule number one is the first term must be a perfect square. Number two, the last term must also be a perfect square. And the expression itself must be a trinomial. And the last operator, which is this sign right here, must be positive. So let's look at an example, and then when we work the example, we're going to look at these steps on how to solve that example. The example we're going to do today is 4 minus 24s plus 36s squared. Alright? Now, before we can apply perfect trinomial square factoring to this, we got to check to see if it fits in our rules. Okay? So, is the first term a perfect square? Is this first term a perfect square? Yes, it is. Okay? Is this last term a perfect square? And the last term is also a perfect square. So, now, is it a trinomial? There's 3 terms here, so that's yes. And then the last operator must be positive. Here's the first operator, which is a minus sign. Here's the last operator, which is a plus sign. So it is positive. So all the rules check out. So let's go ahead and try to solve this problem using the perfect trinomial square method. For step number 1, we got to check to see if there's the greatest common factor. Alright, so let's go ahead and check to see, is there a greatest common factor between these terms right here? And the answer is yes, it is the number 4. Okay, so once we've done that, we got to basically write what's left, or what's remaining once we divide out the number 4 from each one of these terms. So 4 divided by 4 is 1, minus 24s divided by 4 is 6s, plus 36s squared divided by 4 is 9s squared. Let me move this a little closer so it'll be better. Now that we have what's left in the parentheses, sometimes you can try to solve this, or you can try to factor this some more by using some other method. Alright? But in this case, we want to try to solve it using the perfect trinomial square, since that's what we're talking about today. And before we do that, let's check to see if we can actually factor this using perfect trinomial square by looking at the rules. So rule number 1 is the first term a perfect square. Now in this parentheses, this is our first term, and the answer is yes. Is the last term a perfect square? And yes, it is. Okay. Consequently, this is our middle term, which is the negative 6, by the way. I'm sorry. Let me go right here. Negative 6 is our middle term for this particular expression. So let's go ahead and label this based on the formula. So the first term is the a squared, right? Let me erase this so we can go back so you can see a little bit better here. Minus 6s. So this first term is represented by 1, which is the a squared, okay? And then this middle term is our 2ab in the formula, and this last term is the b squared in the formula. So let's go ahead and move on to step 2, okay? So we're going to take the square root of a squared, which is 1, to get the value of a. And the reason why we want to do that is because in the formula, we need the value of a and also the value of b. We don't need a squared or b squared. So if a squared is equals to 1 according to this, the square root of a squared is going to be equal to a. But whatever we do on this side of the equation, we got to do on this side. Okay. Alright. So the square root of 1 is just 1. So this is our value of a. So we've gotten that out of the way. Let's go ahead and find the value of b. Well, we need to get that from b squared. Well, b squared is equals to 9s squared. To get b, we have to take the square root of b squared. Once again, we do the same thing to the other side. On this side, we get b. On this side, we get 3s. So now we have the value of b. And so we've gone through step 1, we've gone through step 2, step 3, and now we're going to look at step 4. We're going to verify that the middle term is equals to 2ab. So here we got an a and b. Alright, so 2ab, all it's saying is that is my middle term equals to 2 times a times b. Well, let's check and see. Here's the 2 from the formula. A is the one we just found right here, which is 1, and b is 3s. Okay, let's go ahead and multiply that together. We get 2 times 1 times 3s is 6s. So, ignoring the signs at this point, right, our middle term is a 6s, so that does verify. So we've gone through step 4. On the last step, all right, basically what it's telling us to do here, all this stuff is saying, is that we're going to draw 2 parentheses, and we're going to plug in the a and the b, the values of a and b, into these parentheses. Now the operator signs for what goes inside the parentheses is based on the first operator. Okay, so the first operator is negative. Okay, as we see here, the operator here is negative, right? That is the first operator. Here's the second operator. So we have to put negative on both of these parentheses. So let's go ahead and plug in the a and the b. All right. So we're going to get a is equals to 1 here and 1 here. Require a b here. We get 3s and 3s here. All right. And let's not forget about this 4, because this factoring that we just did, okay, is based on this right here. All right. This inside this parentheses. These two numbers, these two factors, when you break this down, you get these two. This 4, you can't forget about. All right, it's still there. So this trinomial, when factored, is equal to this 3 factors. All right, thank you.